in new technologies that we have developed.
Yep.
And the idea is that we're extracting the level of coherence of light. It's different property of the light that allow us to get more insight about the depth and velocity.
Right. Hello IPX. We're now going to go into the weird and wonderful world of Lidar and see how you might be able to apply Lidar into areas such as robotics and industrial electronics. We all understand that Lidar is targeted at automotive, but we're now going to talk to Yehuda all about his company Lidwave and how they have a new approach which is looking at Lidar in 4D, which gives you the opportunity to introduce the readers and our community to velocity using Lidar.
Yeah.
Please explain.
Thank you very much for the opportunity. Pleasure to be here today and showcasing our live demo of 4D Lidar, but exactly what it does mean.
Yeah.
We're able to measure not only depth information of objects surrounding the sensor, but also a velocity per pixel of each object in the scene. And that's very important data if you want to make a perception system, because if you have the velocity and range per pixel, you have the equation of motion basically. So from a single frame, you can know what is going on in few seconds.
Right
away.
Right.
Is instant velocity, and this is active sensor, so it's very important for many applications. If it's industrial application, smart cities, monitoring, security, and also of course automotive.
If you were to take Lidar today and say Lidar is an accepted technology, you're bringing 4D Lidar, you've talked about velocity and you've talked about this concept. Just go into a little bit more detail as to what's actually going on there, because it's not it's not a pulse of light that you're sending out. You're doing that. You have a different approach to that. So just talk us through the different approach you have as opposed to pulsing light, and then how you get that back in order to give you your 4D representation and your velocity.
Oh, yeah, that's absolutely great question. So typical Lidar, as you mentioned, using a pulse of light that's sent through the medium towards the targets and reflected back at the speed of light. That's required a huge amount of complexity in measuring that property in the nanoscale timelines. We thought it is too crazy to make it affordable. So we thought about, let's try to make it continuous light toward the targets, and we measure other property of the light that is not related to time, because measuring fast is hard and we want to simplify things.
Right.
So we're able to come with the idea they call FCR. It stands for finite coherent ranging.
Say that again. Finite
coherent ranging.
Finite coherent ranging.
Yeah.
Right.
And we're using basically the...
You don't hear that very often.
Yeah, it is. It is in new technologies that we have developed.
Yep.
And the idea is that we're extracting the level of coherence of light. It's different property of the light that allow us to get more insight about the depth and velocity.
Right. So you're looking at the difference of the light that you get back, rather than how it comes back and how it pulses back. So you're looking at the property of the light.
Exactly.
Rather than the speed of the light.
Yeah.
I think I'm beginning to understand something that is incredibly complicated.
Yeah.
Okay. So we've understood, rather than Lidar we understand.
Yeah.
We then understand that you're then giving 4D Lidar, and we're understanding that rather than the speed of light to deliver that, you're doing it with the property of the light. So that's how you're doing it. Now just quickly explain to us the benefits of that in, let's say, robotics or industrial electronics. Explain to why there's a benefit to that and how that works.
So when you have the velocity information, you basically can classify on the fly what is moving around you, what need to take action, immediate action surrounding you, and take a wiser response at the instant, at the frame level, and not making a software stack that need to be on top of that sensor and experiencing delays in perception. So this gives you an instant accurate data that is very valuable to avoid collision accidents or any type of
Right.
problem in the scenarios.
Okay. So just finally, having explained that, one of the things that I understand that is also one of the benefits that you can bring is that LiDAR is expensive. And what you're hoping to do is bringing this different approach is bringing down a much lower cost, so you can do the same thing that where you might be talking $25,000 to invest in LiDAR, you're going to be able to bring this down with this different approach so you can have a much lower cost for robotics and industrial 4D LiDAR. Is that correct?
Yeah, but there is a good reason why we're able to change the paradigm in this industry. Right now, time-of-flight LiDARs, as you mentioned, pulse LiDARs, using very high-power light sources that cannot be integrated with the detectors. Detectors are very sensitive. We want to separate them specially in order to avoid crosstalk between transmission and reception. Because we're using a different coherent properties of light, we enable to combine the two, because we're using very low power lights, so we're able to integrate everything into a single chip that knows to transmit the light and receive the light from the same pixel.
Right.
And that's give us the ability to produce it at scale.
Much higher scalability.
Yeah.
Right.
At the wafer level.
So you're going to be so because of that one single approach, you're able to then have a scalable model at the chip level that you can go into like a drone, like robotics, and offer this same approach that LiDAR today would be far too expensive to do.
Exactly.
I hope that's an introduction for our IPX community about the difference between LiDAR and 4D LiDAR and then how you do it. To me, it still sounds like magic, so I'm not going to try and understand that anymore. But what I am going to say to you is if you'd like to evaluate it, come to ipXchange.tech and we will connect you with Yehuda and his team, and you can then explore how you can use your 4D LiDAR in either your industrial or robotic or drone technology. Just last question, what kind of evaluation environment do you offer? So if somebody says, I'd like to do that, what's the evaluation process?
So right now we are starting pre-order for the first gen product for industrial application that will be released later this year.
Yep.
So if you have an exciting application that we can contribute with our 4D LiDAR, we will be happy to collaborate.
Right.
And,
so they need to come and talk to you, and then you'll then work out whether or not you can go with
yes,
that.
because right now there is a little bit.
It's early days.
Yeah.
It's early days.
Yeah.
Okay, good, very good. Very nice to meet you.
Yeah,
Thank you for that introduction.
Yeah,
good.
Great.
Hey, yo, where my engineers at?